In this lecture, we will get ourselves familiarized with the different components in a practical transformer. There are a lot of different components in a transformer, and it is difficult to list out all of those components, but the main components are main tank, transformer well, core, HV winding and LV winding, HV and LV bushings, conservator tank, Buchholz relay, breather, radiator, cooling fans, nameplate, explosion vent, thermometer, well level gauge, tap changer, wheel and lifting lugs, and also insulation. We will learn about the installation location of these components in the transformer, but the details of their workings will be discussed later. First component is the main tank of the transformer. The transformer tank is the heart of the transformer setup. Its main job is to surround and protect the important inside parts like the core and the winding. The tank is especially made to hold the transformer well, which is super important for keeping things insulated and cool. This setup helps to make sure the transformer works well and stays reliable by keeping the right temperature and insulation feature in check. Inside the transformer's main tank, transformer has a core and HV and LV windings. The core is specially made of laminated steel and is responsible for creating a magnetic circuit. It enhances the efficiency of the transformer by facilitating the magnetic induction process. Winding consists of insulated copper or aluminum conductors and is crucial for carrying the electrical currents. There are two types of windings, primary winding and secondary winding. The primary winding is connected to the input voltage source, while the secondary winding is connected to the output. Based on the number of turns, they are either high voltage or low voltage winding. The winding in a transformer is also categorized based on the number of turns, determining whether it is a high voltage or HV winding and a low voltage or LV winding. For oil transformer, the whole setting or the core with the windings is immersed in oil. Next component that we want to talk about is HV and LV bushings. In a transformer, bushings are strategically positioned on the transformer tank to facilitate the crucial task of electrical insulation and mechanical support. They serve as essential components providing both electrical insulation and mechanical support to the conductors passing through the transformer tank. These insulating structures provide a pivotal role in preventing the electrical discharges and ensuring that the high voltage within the transformer remains contained. By offering support to the conductors, bushings help maintain their position and alignment, contributing to the structural integrity of the transformer. There are different types of bushings, including oil-filled, dry-type variants, each tailored to specific operational requirements. The conservator tank in a transformer is typically situated above the main tank and is connected to the main tank by a pipe. The primary function of the conservator tank is to act as a reservoir for the transformer well, allowing for the expansion and the contraction of the well as the temperature fluctuates during the transformer's operation. The location of the conservator tank above the main tank ensures that the well remains in contact with the atmosphere, allowing for the exchange of air. The next component we want to talk about is the Buchholz relay. The Buchholz relay is the safety device typically installed in the pipework between the transformer tank and the conservator. Positioned at a strategic point, these relays serve as a protective mechanism for well-filled transformers. The Buchholz relays function by detecting abnormal conditions within the transformer, such as the presence of gas or a rapid increase in the well flow. In the event of a fault, such as an internal short circuit or overheating, gases are produced and accumulate in the relay. This triggers the Buchholz relay, which in turn activates an alarm or initiates the tripping of the transformer to prevent further damage. Next component that we want to talk about is the breather. A breather is an accessory of liquid immersed transformers attached to the conservator tank. They serve as breathing point of the transformer. The breather is typically positioned on the transformer tank, serving as a vital component in managing the transformer's oil condition. Located at top of conservator, the breather contains silica gel which absorbs the moisture from the air entering the transformer. As the temperature variation causes the well to extend and contract, the breather allows the exchange of air, preventing the moisture ingress that could otherwise compromise the insulation properties of the transformer well. Radiators are an essential component for the transformer as they help to dissipate the heat generated within the transformer core. This heat can cause the transformer to overheat and potentially damage it. The radiators is typically located on the outside of the transformer tank. It is made of series of fins that increase the surface area for the heat transfer. Heated oil from the transformer circulates through the fins, releasing the heat to the surrounding air. As the air cools the oil, it becomes denser and falls, creating a natural convection current that drives the circulation of oil through the radiator. The transformers with high ratings are often require forced air cooling system to supplement the natural cooling process, ensuring efficient heat dissipation even under damaging conditions. Next component we want to talk about is the explosion vent. An explosion vent in a transformer is placed to enhance the safety in the event of an external fault leading to a sudden increase in pressure. Typically located on the transformer tank, the explosion vent is designed to release excessive pressure caused by an internal fault, preventing the catastrophic failure. In operation, if the pressure within the transformer rises to a critical level due to the factors such as a short circuit or an electrical fault, the explosion vent opens, allowing the release of gases and pressure. A diaphragm fitted at the curved end breaks at a relatively low pressure to release the forces within the transformer. The electric fans in the transformer are commonly located within the cooling system to regulate and maintain the optimal operating temperatures, typically positioned near the radiator or cooling fins. These fans play a vital role in dissipating the heat generated during the transformer's operation. The thermometer in a transformer is typically located on the transformer tank, plays a crucial role in monitoring the operating temperature of the unit. Positioned near the winding or immersed in the transformer well, the thermometer provides the essential information about temperature conditions within the transformer. This data is vital for ensuring the transformer operates within the safe temperature limits, preventing the overheating that could lead to insulation degradation or other faults. Next component that we want to talk about is the well gauge. The well gauge in a transformer is typically located on the transformer tank, serve as a critical indicator of the well level within the unit. Positioned near the conservator or on the tank's exterior, the well gauge provides the real-time information about the quantity of the well that is present inside the tank. The measurement is essential for ensuring the proper cooling, insulation, overall functionality. Next component we want to talk about is the tap changer. The tap changer in a transformer is typically positioned on the high voltage winding and is crucial for adjusting the transformer's output voltage. Located within the tank, the tap changer allows for the selection of different turns on the winding and enabling the voltage variations to match the changing load conditions. The primary function of the tap changer is to optimize the transformer's performance and accommodate fluctuation in the power system. Wheels and lifting lugs on a transformer are positioned on the lower section of the unit, facilitating its mobility and transportability. Typically located at the base of the transformer tank, wheels allows for easy movement during the installation, maintenance and relocation. Additionally, lifting lugs are strategically placed on the transformer's upper structure, providing secure attachment points for lifting the equipment. The dual system enhances the versatility of the transformers, enabling efficient handling and transportation. When required, lifting lugs allow for safe hoisting, while wheels simplify short distance movement. The nameplate on the transformer is typically affixed to the exterior of the unit, providing the essential information about its specification and operating parameters. Usually located near the transformer's terminal box, the nameplate displays key details such as rated voltage, current, power capacity, impedance, and other critical technical data. It serves as the reference for operators, technicians, and maintenance personnel, offering comprehensive information about the transformer designs and capabilities. Next, we want to talk about the insulation inside the transformer. The insulation in the majority of the transformer consists of both well and cellulose or paperboard. The solid insulation is divided into major and minor insulation structures. The major insulation structure system includes barrier, spacers, clamps, while the minor insulation consists of winding insulation, The insulation in a transformer is an integral to its operation and is primarily located in the core and winding assembly. Situated between the conductive components such as the core and the winding, insulation prevents the electrical breakdown and ensures the effective isolation of the different voltage level. The transformer tanks also contribute to the insulation, acting as a protective enclosure. Additionally, insulating oil within the tank enhances the dielectric strength of the transformer, providing an efficient cooling medium. There are a lot of monitoring devices inside the transformer. We have already talked about thermometer and oil level gauge. There are also pressure relief device, winding transformer indicator, oil transformer indicator, pressure and vacuum gauge, and also tap position indicator and moisture meter. Devices are included in the transformer in order to check different levels of temperature, moisture, and pressure inside the transformer. This concludes our discussion for this lecture. In the event that you have any question regarding this presentation, feel free to post them in the comment section and don't forget to hit the subscribe button. See you in the next one.